Welcome. This video walks through the engineering of a small commercial site using the LumInsight Provisioning Tool. The site, Echelon's corporate headquarters, contains 4 single head poles to the south and 3 tandem-mounted poles to the east side of the building as shown in this bird's eye view. The workhorse of the outdoor lighting system is the LumaWave CPD 3000 Outdoor Lighting Controller, or OLC. It communicates operating and fault data over existing mains power up to 277 VAC. It switches loads up to 5 amps and will dim fixtures that support a 0 to 10 volt control interface. Each device is uniquely defined by its unique ID. The Smart Server Lighting Segment Controller uses standard TCP/IP protocols to manage scheduling, collect data, and control the lighting system. It can operate independently of the LumInsight CMS for days while it stores operating data for eventual transfer when internet connectivity is restored. The LumInsight Provisioning Tool is used to engineer the system. It defines the segment controller configuration, OLC and sensor devices, logical control groups, and scene definitions that are used for dimming profiles. Each lighting segment controller is first provisioned with this tool before integration into the LumInsight CMS. The process starts by creating a new project from scratch or based on a previously developed project. A lighting services company will build a series of starter projects that include definitions for fixtures previously built to speed the engineering process. Here we are starting with a new project from scratch. It is good practice to provide a meaningful name and to provide a brief description of the project for future at-a-glance review. Saving the project periodically is also an important habit to develop. Our first task is to define the Smart Server Lighting Segment Controller that will manage the operations of lighting at the site. A unique name for the segment controller is set, along with the IP address that is used by the CMS to reach the site. The person managing IP connectivity to the site will provide this address for you. We'll go ahead and fill out the description with the site description, and then we'll locate the site's time zone as well as its position within the OpenMaps interface. Again, we're giving precise geographic coordinates for the device for navigating in the future using the map interface in the CMS. The TCP/IP tab defines the segment controller's local area network settings. When using cellular data network, typically a gateway is in front, and putting the ILAN on a private 192 address is very typical. Setting up the DNS settings as well as the host name are very important. Again, you'll consult your network administrator for what needs to be done in your situation. The GPRS tab shows support for deprecated serial modems that are difficult to source and typically not recommended. The default time servers are set up for North America. Set them accordingly for your region. The web server is used to define the address of the CMS web binder service that is used by the segment controller to push data logs. This address is typically the same from site to site, so the tool will always present the last used configuration in this tab. For the channel driver, it's important just to leave the default settings. And finally, in sites that have segment control, sometimes there'll be an energy meter. We support the LCore watts-on meter that is able to log the data of the energy used by the entire lighting segment. With the segment controller defined, it is now time to design the control elements of the system by defining groups, scene tables, and fixture definitions. In this project, we need 2 groups to manage the poles on the south and east portions of the parking lot. Groups are typically scheduled on and off with the astronomical clock, but may also respond to inputs monitored by the segment controller. Here we are going to configure operation of the dusk dawn sensor and the manual on switch. Control group light levels are scheduled using scene tables. A scene table defines a light level and optionally references an unoccupied scene for systems that are equipped with traffic occupancy or TOS devices. In this example, we will use 2 simple setback scene tables to program the east and south groups with different dimming profiles because these areas of the parking lots have different utilization needs late at night. The CPD 3000 uses configuration settings to define the operating characteristics of the light source it controls and monitors. We will use the Fixture Definition tab for this task. Let's start with the tandem pole configuration. In the Control tab, we can limit the dimming control signal and, if necessary, define a cool-down warm-up time if the light source demands it. In the Alarm tab, we set the various triggers for the faults. Central to proper alarm configuration is setting the power profile. The power profile defines normal operating power consumption at 5 specific level commands. Finally, in the Characteristics tab, we define the light source type, the expected lifetime, and the baseline power usage for energy reporting. Let's go ahead and define the other fixture type in QuickTime. Let's review what we've accomplished so far in the LumInsight Provisioning Tool. We defined the segment controller settings, its unique name, GPS location, TCP/IP configuration, and its connection back to the CMS for data reporting. We've defined control groups, scene table presets, and fixture definitions. In the next part, we'll define the actual control network.